Why DMA is used? A direct memory access is a mode of data transfer between the memory and IO devices. This happens without the involvement of processor. We have two more methods of data transfer IO, programmed IO and interrupt driven IO. Let's review each and get acknowledged with their drawbacks. So in the programmed IO, the processor keeps on scanning whether any device is ready for the data transfer. If an IO is ready, the processor fully dedicates itself in transferring the data between IO and memory. It transfers data at a high rate, but it cannot get involved in any other activity during the data transfer. This is a major drawbacks of programmed IO. In the interrupt driven IO, whenever the device is ready for data transfer, then it raises an interrupt to the processor. Processor completes executing its ongoing instruction and saves its current state. It then switches to the data transfer while causing a delay. Here, the processor does not keep scanning for peripherals ready for data transfer, but it is fully involved in the data transfer process. So it is also not an effective way of data transfer. So the above two modes of data transfer are not useful for transferring a large block of data, but the DMA controller, the direct memory access controller, completes their task at a faster rate and is also effective for transferring a large data block. Hence, direct memory access is needed for the data transfer without the intervention of the processor. Let's see how the data transfer is going to be happen over there. So the DMA controller transfers the data in three modes of operation: burst mode, cycle stealing mode and transparent mode. Let us see one by one. What is a burst mode? Here, once the DMA controller gains the change of the system bus, then it releases the system bus only after completion of data transfer. Till the CPU has to wait for the system bus. This is going to be called as burst mode. Second one, cycle stealing mode. In this mode, the DMA controller forces the CPU to stop its operation and relinquish the control over the bus for a short term to DMA controller. After the transfer of every byte, the DMA controller releases the bus and then again requests for the system bus. In this way, the DMA controller steals the clock cycle for transferring every byte. Hence, this mode of operation is going to be called as cycle stealing mode. Cycle stealing mode. Third one, transparent mode. Here, the DMA controller takes the charge of a system bus only if the processor does not require the system bus. So during that time only the mode is going to be get active and it's going to do the process of data transferring. Hence it's going to be called as transparent mode. Let us discuss how the DMA controller is going to work. So the DMA controller and its working. Here the DMA controller is a hardware unit that allows the IO devices to access memory directly without the participation of the processor. Here we will discuss the working of DMA controller below. The diagram which have been shown is DMA controller and its working. Whenever an IO device wants to transfer the data to or from the memory, the DMA request to the DMA controller. So the DMA requests the DMA controller, the IO device, which is going to request the DMA controller through DRQ. The DMA controller accepts this DRQ and asks the CPU to hold for a few clock cycles by sending a HLD signal, that's nothing but hold request signal to the processor. So when a device requests a DRQ, the DMA controller sends an request line, hold request line through the processor. Then CPU will acknowledge the hold request line from the DMA controller. Okay, so the processor receives the hold request line from the DMA controller and it's going to send and acknowledge from the processor to the DMA controller and relinquishes the bus and sends the hold acknowledgement to the DMA controller. After receiving the hold acknowledgement from the processor to the DMA controller acknowledge the IO device through direct memory access controller acknowledge DACK to the data transfer can be performed, and DMA controller takes the charge of the system bus and transfers the data from or to the memory. Okay, when the data transfer is complete or accomplished, the DMA raises an interrupt. The DMA raises an interrupt control to the to let the processor that the data transfer has been finished, and the processor can take control over the bus, again start processing while it has left. Okay, such a way it's going to do the process. Now the DMA controller can be separate unit that is shared by the various IO devices, or it can also be a part of IO device interface. Such a way the DMA access, the direct memory access controller, is going to work with the processor to access the data from the memory or to the IO device. Such a way it's going to do its operation. Let's see how the direct memory access is going to be having its own diagram over there. After exploring the working of DMA controller, let us discuss the block diagram of DMA controller. So the block diagram which have been shown over there, whenever or where a processor is requested to write or read a block of data, that is a transfer of block of data, it instructs the DMA controller by sending the following instructions. Let us see the instruction one by one. The first information is whether the data has to be read from the memory or the data has to be written to the memory. It passes this information via read or write control signals. Okay, read or write control signals, read signal or write signal control lines that is between the processor and the DMA controller. It's going to be called as control logic. With the help of a control logic, it's going to access the memory for the read operation or write operation. Second one, the processor also provides the start address for the data block in the memory. From wherever the data block in the memory has to be read or whether the block of data has to be written into the memory. The DMA controller stores that or thus in this address register, and that is also called as starting address register. Starting address register. That's the second one. Third one, the processor also sends the word count. The processor also sends the word count. How many words are to be read or written. It is stored in the, its information is going to be stored in the data count or word count register. In this word count register, this processor count is going to be stored over there. How many data are to be read or how many data has to be written, that will be stored in the word count. Then the last one, the most important, the address of IO devices. The address of IO devices, this information is going to be stored in the data register. Okay, the most important is the address of IO devices that wants to read or write the data. This information is going to be stored in this data register. Such a way, the control logic is going to be used for accessing the control signals read or write, and the starting address will be stored in the starting address register. The word count will be stored in the word count or data count register, and the main thing, the address of IO devices will be stored in the data register. So this is the block diagram of direct memory access. Let us move on to the advantages and disadvantages of the direct memory access. Coming to this advantage, transferring the data without the involvement of the processor will speed up the read or write task. So the execution time will be fast, the DMA reduces the clock cycle which is required to read or write a block of data. Then implementation of the DMA also reduces the overhead of the processor. These are the advantages of this particular DMA access, direct memory access. And coming to the disadvantage, it's as it hardware unit, it would cost to implement the DMA controller in a system, so a bit of costlier. And as usual, a cache coherence problem can occur while using the DMA controller is going to be get used over there. So these are the disadvantages of this DMA controller. So I'm going to summarize this particular DMA process as a DMA is abbreviated or abbreviation of a direct memory access, and the DMA is a method of data transfer between the main memory and peripheral devices. The hardware unit that controls the DMA transfer is a DMA controller. The DMA controller transfers the data to and from memory without the participation of the processor. The processor provides the start address and the word count of the data block within a transferred to or from the memory to the DMA controller, and frees the bus for DMA controller to transfer the block of data. DMA controller transfers the data block at a faster rate as data is directly accessed by IO devices and is not required to pass through the processor, which saves the clock cycle too. The DMA controller transfers the block of data to or from the memory in three modes: burst mode, cycle stealing mode, and transparent mode. So DMA can be configured in various ways. It can be a part of individual IO devices, or all the peripheral attached to a device may share the same DMA controller. Thus, the DMA control is a convenient mode of data transfer. It is preferred over the programmed IO and interrupt driven IO mode of data transfer. Okay, hence DMA is going to be more effective for the data transfer between IO device and the memory. So in this, I take this privilege to thank you people for watching this video of module 3. So we will see shortly in the next module, module 4. Thank you for watching this video. Thank you.